we've looked at what our factor theorem and remainder theorem help us know. So we know that by using the remainder theorem, whatever the remainder is in our synthetic division is the y value. So using that, we can know that if our remainder is 0, then the thing that we divided by is a factor, or an x-intercept, or root, solution, or 0. Okay? So if we have this polynomial, and we know that 3 is a 0, that means that I can divide by 3 to get my polynomial knocked down to a lower power. So for example, on this one, because it's a 3, this is not written as x plus or minus a number. This is the actual x-intercept, so I keep it the same sign. So I 3, and then I'm going to synthetically divide this polynomial. Okay? So I'm looking here, this is cube squared 1 none. So then it's in descending order and I haven't skipped any powers. So I put the coefficients 2, -3, -11, 6. So I bring down the 2. 3 times 2, remember we multiply these two, that gives us 6. And then I add straight down, so -3 plus 6 gives us 3. So now I do 3 times 3, which gives us 9. And then I do -11 plus 9, which gives us -2. And then I do 3 times -2, which is -6. And then I add straight down, which gives us nothing, right? Which is what I should be anticipating because it told me that this is a 0, right? So this 0 that we get here means that's a 0 as in a root, solution, x-intercept, that kind of thing, factor, okay? So now, if you remember from our synthetic division, this part is our leftover polynomial. So I can figure out what that is by taking power and going 1 below that. So this is going to be 2x squared plus 3x minus 2, right? So then what I can do is I can use my skills from before and solve this using our skills to solve quadratics. So if I'm solving a quadratic, I can solve it using factoring or completing the square or the quadratic formula. Okay, so factoring is always the quickest. So I'm going to check and see, well, almost always the quickest. So I'm going to check and see, can I factor this? So I'm going to see, can I multiply to -4, but add to 3? Well, I can. I use 1 and 4, where 4 is positive and 3 is negative. I double check my signs. That multiplies to -4, but adds to +3. I'm going to pay back my 2 value, so I put the 2 on top here, and then I reduce, or see if there's a common factor. So 2 goes into this 1 time, 2 goes into 4 twice. Okay. So I get my parentheses as 2x minus 1 and x plus 2. Now you can quickly check and say, okay, this is 2x, which gives us 2x squared. This is -2, and then this is -1 and +4, which gives us +3. Okay. So if I finish solving this, we get our x-intercepts are at 1/2 and at -2, with a multiplicity happening both at 1. But don't forget, we also had this x-intercept over here, right? So I want to add that to my list, okay? And we have a multiplicity of 1. Now, sometimes because we're using multiple ways to solve, you'll have a multiplicity that will show up with your synthetic division and then will show up over here. So there is another way that we look at multiplicity is how many times it shows up as an answer. So if we got a 3 here, and suppose this was a 3 or a -3 to give us a 3, instead it would show up twice with these being 3, so then that would change my multiplicity to a 2. Okay. So sometimes your multiplicity is really how many times it shows up. So now I know all of my answers to this equation. Because I knew 3 was a 0, I knocked it down to a quadratic, and then I solved our quadratic like we do normally. So our answers are 1/2, -2, and 3. Okay? So we can do that same kind of thing with this one. Again, we know that -1 is a 0. I could have said it's a root solution, or that I could have said that x plus 1 is a factor. Remember, if you're doing it as x plus or minus a number, you change the sign when you synthetically divide. So -1. If it's not written like that, you keep the sign the same. So this is why it's a -1. Okay, I look at my my polynomial, so cubed, squared, 1, none. So I haven't skipped anything, and it's in descending order. So I've got 15, 14, -3, and -2. So I bring down the 15. So I do -1 times 15 is -15. I do 14 plus -15 is -1. -1 times -1 is +1. I do -3 plus 1 is -2. -1 times -2 is a +2. And then -2 plus 2 gives me nothing. Now I should be anticipating nothing because it told me that this is a 0. So I'm anticipating this is a 0. So if I don't get a 0 there, I should think I screwed up somewhere. Either in your arithmetic here, or you forgot to change the sign, or you changed the sign and you weren't supposed to change the sign. So this was a cube, so it knocks this down to a squared. So we get 15x squared minus x minus 2 equals 0. So I'm going to finish solving that. So I'm going to do -2 times 15. So we're multiplying to -30, and we're adding to -1. So I can use 5 and 6, with the 6 being negative. I double check my signs. That's really -30. That's really a -1. When I add them, I pay back my 15, and then I look for a common factor. Here I have a common factor of 5. So 5 goes into this one 3 times. 5 goes into 5 once. I also have a common factor over here. So I have a common factor of 3. 3 goes into 15 5 times. 3 goes into 6 twice, and I keep it negative. Okay. So notice our common factor here was 5. Our common factor here was 3. If we do 5 times 3, that's our 15. So that's another way to just double check on some minor things. So this gives me my factored form is 3x plus 1 times 5x minus 2 equals 0. Remember, when we're solving and you've got coefficients in front, you change this sign, divide by that number, because what you're really doing is 3x plus 1 equals 0. So you subtract the 1. So then we divide by the 3. So x is -1/3. And then here, x is 2/5. Remember, change this sign, divide by this number. So we get 2/5. And then don't forget about the x from over here, that we also have x is -1. This came from a first power. This came from a first power. None of them are repeated. So each one has a multiplicity of 1. So it'll be odd and crossing, multiplicity of 1, odd and crossing, multiplicity of 1, odd and crossing. Okay? So that's how we can use that to help us find the solutions, or roots, or zeros, or x-intercepts, or our factors of a polynomial.